Good morning, everybody. My name is Bendegúz. I am also from the Institute of Nuclear Techniques, and I will be talking about another advanced reactor project. This one is called SaFeG, which stands for Safety of Gas-Cooled Fast Reactors Through Innovative Materials, Technologies and Processes. And so to start, what is this gas-cooled fast reactor? Well, altogether there are 6 different promising advanced reactor technologies supported by the Generation 4 International Forum. And so each of them focuses on the most important challenges of nuclear energy. And one of these is gas-cooled fast reactor, GFR. Its main advantage is that it offers very high core outlet temperatures, which allows for high efficiency electricity production, and also the possibility to close the nuclear fuel cycle by using significantly, or creating significantly less nuclear waste than current reactors. So the reactor here is called the Allegro reactor. It is supposed to be the prototype for this GFR technology. Its point is to demonstrate the viability of all the technologies connected to GFR. It's been under development for about 15 years, and in the last few years it is under development mainly by the V4 countries, together with France, the UK and Japan. And our current project, the SaFeG, received 4.5 million euros of Horizon 2020 funds. And so here the most important conceptual questions are already answered. So the current project focuses on the aspects of safety through 3 different areas. First is material science, where we try to develop advanced materials that can withstand the high temperature and high radiation for a long period of time. Also, some of the tasks are focused on the fuel cycle and the proliferation resistance and sustainability of the fuel cycle. And of course, the engineered safety systems themselves. Most importantly, the development of a fully passive decay heat removal system and the development of a reactivity shutdown system. So what is the contribution of our institution? Well, we employ 4 different research methods. First of all is the system thermal hydraulic codes. We use a software called APROS to analyze the transient behavior of the system. Here our task within the project was to improve the design of this decay heat removal and to optimize the general transient response during accident scenarios. We also have a particle image velocimetry laboratory where my colleagues have conducted a number of experiments to help with the validation of our computer codes. And we also organized a CFD benchmark activity for all the participants of the project. Next, we employ quite a bit of CFD modeling in order to analyze the detailed temperature distribution of the fuel rod bundles. And here, my colleagues have made significant improvements in evening out the temperature distribution within the fuel by introducing little fins and vanes onto the spacer grids of the fuel rod bundle. And very interestingly, combining these 3 methodologies is very useful within our latest research effort, which is to develop a more accurate method of heat transfer calculation for this APROS software. And to do this, we are highly relying on the CFD and PIV measurements. And last but not least, our reactor physics department uses Monte Carlo methods for optimization of the neutronics and the reactor shutdown system of the core. And yeah, that concludes my brief introduction to SaFeG. So thank you very much for your attention.